So as we start for 7, let's do a quick flashback to 4-6. So change of base, we learned that lovely thing back last week. We'll do a little review here just as a reminder. When you see something, normally we say, hey, this number to what power gets me to this? Well, sometimes that's not going to be easy or even like possible in our brain. So what we do instead is we bust out the calculator. I've had some of you ask me, Hardy, are you just going to show us at some point how I can just plug that all in at once in my calculator? No, and here's why. Because not all calculators are going to have that button. And so I don't want you getting stuck using different calculators, not knowing what to do. What I'm showing you works on every calculator. So the biggest thing on using change of base is that parenthesis right there. Because if you forget to close it, you are going to get a different answer. So we got to remember to close parentheses. And always that it's the of value divided by the base. Or some people say the physically big divided by physically little. Either one works. We can get decimals. We're going to the nearest hundredth. We go about our business. This works for anything. Okay? Decimals, it works. Even fractions, let's play with this. Even fractions, this works. Just to kind of get us warmed up here. And I can't stress it enough, when we do change of base, it doesn't mean you always do the log of the larger value divided by the log of the smaller. It's all about where they're placed. That always is going in the denominator. Every single time when we're working those through. Okay. So when we chatted last, though, about solving with these, we were hoping for one of two things. We were hoping that there was a log of the same base on both sides, or if there was only one, that there was a number on the other side that I could get a value for. One small issue, though. Sometimes you're going to run into a logarithm where that's not possible. So what's going to happen in that instance is we're going to stretch this out a little bit more than that would necessarily work. So instead of doing the crazy example first, we'll do the crazy example when we get to it down here and kind of describe that through. Let's start with some things that are a little more normal, that are going to get us feeling a little bit better as we start this. So I look here and I'm like, okay, Hardy, I don't see logs anywhere. So what do? We're looking totally here to the side where that x exponent's at. That's what we got to deal with. And so, quick reminder, we'll just jot it up here. Any base and its log are inverses. They, air quote, cancel each other out. So here on number 5, no, I cannot just divide by 7 and call it good. That's not 7 times x, that's 7 to the x power. So the only way I can get that 7 out of there is using the log of this base. So what we're going to do is we're going to take both sides to log base 7, because hopefully at this point we know that that would zap that out and just leave me with x, which is what I wanted anyway. And here, this is a change of base because I have log base 7 of 80. So if I went to my calculator, I'd do log of 80 divided by log of 7. Base of my of divided by log of my log of my of value divided by the log of my base. There, I finally spit out what I meant. And yes, you have to have the log with each part. And we're going to the nearest hundredth. Okay. Okay, and we're set. So anytime we're dealing with those, that's the deal. And as long as we only have an x on one side, we'll see how to deal with that when it's not here momentarily. All we're going to do is keep doing that same thing. We got to get rid of the 4. We're going to use the log of that base. And you always are using the same log of that base on both sides. So it's not like I can do log of 4 over here and log of 100 over here. We can't do that in algebra. We can't do that here. So those go away. X plus 1. Let's do a little change of base action here. Oops. Log of 100 divided by the log of 4. It's 3.32. And now life's pretty easy. Just subtract the 1. Now, you still do need to pay attention to your answers, especially if you get negative ones, because, as we've said before, you can't take the logarithm of a negative. But you're like, wait a minute, Hardy, I don't take any logarithms in the original problems. That's true. So we may not have to be as scared because these logs we're using as opposites, not as an actual answer. So again, not as much caution needed, but we want to be careful nonetheless. So I haven't done this in almost a week now because I haven't seen you in forever. Freeze frame. Number 7. Just follow along with what we've been doing. Give it a shot. We'll see if we're on a roll here, if we need to catch a little more of this as we go. Those of you that are uncomfortable with decimals, you want to make sure that you get more comfortable because there's going to be lots of them in this section and the one that we're going to be dealing with tomorrow as well. Just to give you a little heads up here. A little bit more time here to get that set. And we'll see if we're ready to go after the beast here. All right. Log of 3.6, because again, it's always the log of where you're trying to get to your x. The other side just adjusts. And so we work that out. We get our x's alone. We work that through. But again, you've noticed in all 3 of these, we have x on one side, we have a number on the other side. What in the daylights are we going to do if there's x's on both sides? So here's the problem that we run into. I can't just do log 2, that'd cancel that, but then this isn't going to work. And if I do log 3, this is going to work and that's not. And we can't use different logs for both sides. That's illegal. So, oh boy, these are the ones that get the double star, hold your nose, because it's going to be a ride here. So here's how this works. We're actually going to use log base 10 to solve this. And here's how that goes. So we're going to take both sides to regular log, which we assume is log base 10. So here's what that looks like. So both sides, we are just going to log here at the start. Write as small as you can, because we're going to need a little room here. Okay, plain old log. So here's where the fun starts. We're going to use something we learned last week as well. We're going to expand this to be able to get to x. So when we expand, exponents become coefficients. So this x plus 5 and this x minus 2 are going to be coming down in front of these logs. Now at first you may be like, how are we actually making progress here? This kind of looks like we're going backwards. We are not going backwards, I promise you. We log it up. Pluck that out here. Now, it's going to start to come into show here very quickly. So here's what we got to do next. We have got to start working on getting rid of these parentheses. Well, right now, I can't do that yet. So, in order to make this a possibility, we're going to do a little distributing. So I said, we're going to write small, but it's going to come together quickly. So we're going to have x times the log of 2 plus 5 times the log of 2. Literal distributing equals x log of 3 minus 2. Log of 3. Change colors again here. She's like, okay, again, how are we making progress? Well, remember, we're trying to solve for x. So our next job is going to be to get all of our x terms on one side and all of our non-x terms on the other. So here we go. I'm going to condense this a little bit. So I'm going to subtract this x log 3 over here. So let me show you what that looks like. So this moved over, and this 5 log 2 gets to go to the other side where it's just the numbers. So over here, when I subtracted that over, I add negative 2 log of 3, and this is coming over with it. You're like, Hardy, this is not fair to do on the first day of the week. I know, but we're almost there. So what we've done by using that base log is given ourselves the ability to get these x's out of the denominator because they became our coefficients here. Did a little distributing with our log base 2. So my x gets it, so does my 5. My x gets it, so does my minus 2. And then to get to this final step, we wanted all of the logs with an x on one side. So I left the x log 2 alone, subtracted the x log 3 over. So I've got my common term here. And then this doesn't have an x, so I subtracted it back over to the side where my coefficients are just numbers. Here's why I'm doing that. Because now we can't start a week without using the Algebra 2 F word. We have a common term now. We can factor out x. And here's where the end is. So if I take x out of each of those, I'm not doing a darn thing to the right side. Just did that on the left. Oofda, Hardy. Oofda. Finally, we have one x, and we can actually get to it. It's not stuck with anything else. So, just like we do in any algebra expression, once I have x there, what do I do to get x alone? I'm multiplying it by this quantity, this set of parentheses. We're going to divide both sides by that quantity. There's my x equals. You're like, what in the heck? How do we put all this in here? Very simply, except I'm going to put parentheses around it. And I got to be really careful as I type. That's all I'm going to say. Parentheses. Why do I need them? Because if I don't, the calculator's not going to do this in the right order. So negative 2 log of 3, close my parenthesis, minus 5 log of 2, close my parenthesis, close the big one. Now we've grouped that whole numerator together. Divide by, and one more time, log 2, close it, minus log 3, close the log, close the denominator. If it scares you that you're going to forget parentheses with this, there's a lot of parentheses here. You could just type in the top hit enter, type in the denominator, hit enter, and then just divide the numbers. I'll show you that because that might be a better option for some of us here. Oofda. So if you were afraid of the other issue that I just spoke of, here's what you could do instead. So there's my numerator. There's my denominator. So I could do like negative, whoops, if I type it in, negative 2.45. I am going to take it out though. Divided by that answer, I get the same thing. So you have options. Is there a way of shortcutting this? Nope. Not when the bases aren't the same. Nope, can't do it. Can't do it. But the only time you have to do this is if you have a variable exponent on both sides. If one side is just a number, you can do what we did in the first three. We don't have to do this. And this doesn't happen a ton. That's the other good news. Most of them are going to be like 5, 6, and 7 were. So, I am not going to freeze frame you. I'm not that awful. I do want to run one more through so you can see it, especially with having an example right next to it. We're not doing 10. That's overkill. We'll do 9. We'll call it good. So I'm like, okay. Different bases. Oh, x is on both sides. All right. So we're going to log both sides, except we know what to do now. So 3x log of 9. Because again, I could have just written log 9 of that and then brought it down. But again, I can kind of see here how this is going to work. And then we've got 5x plus 2. Okay, exponents became coefficients of each of those logs. And so once we got here, we're just going to kind of use, this is our example again. We're like, all right, well, Hardy, wait a minute. So when I've got this one, what am I distributing to? You're not. There's only one term here. So this one stays the same. Because I'm not doing like 3 log 9 and x log 9. There's no plus or minus to distribute to. But over here there is. So 5x log of 4 plus 2 log of 4. So only if there's a plus or minus, a binomial there, do you have to distribute. Otherwise, it just stays the way that it is. But now we still have got to get all the x terms to one side. So these two both have x terms. So bring the 5x on over. And then this 2 log of 4 is just left hanging out on its own over here because it's the only one of our terms that doesn't have. Oops, my log is supposed to, my parenthesis is there, not there. You don't want to start causing problems here. So I look and I'm like, okay, now what's next? So all the x's are together. Okay, we take out the x. So let's take out the x here. Whatever is left, when I take the x out of each term, so the x has been factored out, so the 3 is left in the first term, the 5 is left in my second one. And we're almost to the end. Because again, now I can, what color do I want to use? I'm going to use this. There's what I want to solve for. I'm multiplying by all this stuff. So I'm going to divide by all this stuff. And again, if you are comfortable enough that this is going to work clean for you without writing all of that out, I mean, you can be my guest. But what we're going to look at here, let's see. So we got this. If we're doing it all at once, get that first parenthesis in there because we're going to let the calculator know what's up. So 2 log of 4, that's my whole numerator. Denominator, start with a parenthesis. 3 log 9 close minus 5 log 4. Close the log, close the denominator. Heard you got a negative, is that okay? It is. Because as we mentioned before, there's no logarithms in your initial problem. As long as there aren't logs in the initial problem, you don't have worries. You can get positives and negatives. We deal with that with these fraction terms all the time and get that worked in. So, here's what we're going to do. You're like, wait, that's the end of the note. That's it. That's it. 4, 7, that's the end. Where? Freeze. Okay, freeze. So, here.